Howdy guys, this is Mr. Crawford, and we're going to cover topic 2-2, patterns and linear functions, which we covered on Friday, September 11th. Okay? Okay. So here we go. Vocabulary. Essential understanding. The value of one variable may be uniquely determined by the value of another variable. Such relationships may be represented using tables, words, equations, set of ordered pairs, and graphs. Okay? Awesome. Let's see, key concept, function. Okay, so problem one, here we go. What we're gonna do is figure this out. So in the diagram, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent the relationship using a table, words, an equation, and a graph. Okay? Okay. So let's see, what is the relationship? So between the number of rectangles and the perimeter. All right. So we're going to have an x and a y because we're first going to do our table. So x and y. We're going to go ahead and say that x is the number of rectangles and y is the perimeter. Okay? So x, the number of rectangles, the first number of rectangles is going to be 1. You have one rectangle. So 1. And the perimeter of the rectangle is found by adding all the sides, right? So remember, your perimeter is going to be 2L plus 2W. So for the first rectangle, let's write it right here. P equals 2L plus 2W. So let's see. 2 times L. What's your length? 6, right? So 6 plus 2 times length, which is 1. Hold on. 2L, yeah. And then 2 times the width, which is 1. So 1 equals, so 2 times 6 is what? 12. 2 times 1 is 2, so that's 14. So your perimeter will be 14. Okay, now let's go ahead and find the perimeter when you have two rectangles. So x will be 2. So for your equation, you're going to have 2 times your length, which is 6. So 2 times 6 plus 2 times, you're going to have 1 plus 2, which is 2 for your width. So 2 times 6 is 12, plus 2 times 2, which is 4. So 12 plus 4 is 16. So your perimeter is going to be 16. Now for your 3 rectangles, so you're going to have a 3 for x, and you have 2 times your length, which is going to be 6 still, plus 2 times your width, which is now 3. So 2 times 6 is 12, plus 2 times 3 is 6. 12 plus 6 is going to equal 18. So that's your perimeter. And last one, when x is 4, 2 times 6 for your length is going to be 12, plus 2 times w, which is going to be 4, is going to be 8. 12 plus 8 is going to equal 20. Okay, so we have the table. Our table is right here. Done. Now, using words. Now, in order to use words, we have to describe what happened in order to get the perimeter. So depending on how many rectangles we have, what happens when we to get the perimeter? So pretty much, let's look at the equation we have, which is so P equals 2L plus 2W. What is unchanging? And what is unchanging is always going to be this 2 times 6, 2 times 6, 2 times 6, 2 times 6, which is going to be 12. 12 is always the same. So we're always going to be adding 12. So let's go ahead and just write that out. Add 12 and put it towards the end. Okay. So after so we have to add 12. So now we need to see what is changing, because that's going to be your variable. It's going to belong with your independent variable. So when you have one rectangle, your width will be 1, right? You're multiplying by 2. When you have 2 triangles, that's also your width. So that's going to be multiplied by 2. 3 rectangles, that's going to be 3. So to write this out, you would first write the output. And the output is going to be your y, which is the perimeter. So go ahead and say the perimeter is found by multiplying the number of rectangles by what? So if we have one rectangle, you put it in here, and you multiply it by 2. You have 2 rectangles, you plug it in here, and you have, and you multiply it by 2. You have 3 rectangles, and you multiply it by 2. We're always multiplying by what? 2. So the perimeter is found by multiplying the number of rectangles by 2. And what do we always going to add? And adding the constant, which is going to be 12. And adding 12. So that's written out with words. So after that, we need to do the equation. So the equation is even easier because we already have it right here. Okay, we already have it written out. So we're always going to have 2 times 6, which is going to be 12, plus 2 times the number of rectangles. But we want to have just a variable in for that number of rectangles because it can be any amount of rectangles. So instead of using a number, use a letter, which I would use x. And our equation is always going to equal an output, which is usually always going to be y. So your equation will be y equals 2x plus 12. Lastly, we need to graph this. So I'm going to go ahead and move on to a new page, and we're going to plot these points. Which it was 1, 2, 3, 4. And 14, 16, 18, and 20. So 1, 2, 3, 4. And then 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. So for a line, by definition, we only need 2 points. So I'm going to go ahead and say 114. So that's going to be 2, 4, 6, 8, 10, 2, 4, that's 14. So 114, let's plot that. So 114 and 420, which is going to be right here. So 420. These are 2 points. Now to draw a line, just draw a line going between them. And there we go. That's your graph. Okay, so that's example 1. Let's go to example 2. Representing a linear function. So we have this table and a paragraph. So let's go ahead and read this. The table shows the relationship between the number of photos x you take and the amount of memory y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. So let's first answer this first part. Is it linear? And in order to figure that out, we need to see if the change in x and the change in y are constant. So 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1. So that's constant. Good. 12 to 9 is -3, 9 to 6 is -3, 6 to 3 is -3. So that checks out. They're both constant. So we would say yes, this is a linear function because the change in x and change in y are constant. Okay, let's see. So we answered that question. So now we need to describe the relationship using words, an equation, and a graph. So using words, okay, we're describing the relationship between the number of photos, x, and the amount of memory, y, in megabytes. So we're always going to start off with the output. So we're going to go ahead and say the amount of memory left on your memory chip on your camera's chip is, so first off, what do we start off with? How much memory do we start with? So with 0 photos, we have 512 megabytes. So let's go ahead and say that. The amount of memory left on your camera's chip is 512 megabytes. And then what happens per photo? Per photo, so with 1 photo, you subtract 3. The next photo, you subtract 3. So that's what we would say. The amount of memory left on your camera's chip is 512 minus 3 megabytes per photo, because per every photo, you're taking away 3 megabytes. Okay, so that's using words. So words, check. Now equation is easy as well, because all we do is take the description that we just made and convert it to an equation. So we know that the amount of memory is y, is stands for equals. So let's go ahead and put y equals. And then the first number we come across is 512. So go ahead and write 512. And then as you see here, we have a minus, so put a minus. And then 3 megabytes per photo. So 3, and then per photo, if you see right here, is x. So then that's the equation. And last step, we're going to go ahead and graph it. So let's go ahead and go to the next page. We had 0, 1, 2, and 3. It was 512, 509, 506, and 503. Okay, so we're going to graph it. 0, 1, 2, and 3. And then, as you see here, these are really big numbers. So let's go ahead and ignore the 5s for now. And we're just going to plot 3, 6, 9, and 12. So 3, 6, 9, and 12. And again, we only need 2 points to make a line. So 0, 12. So 0, 12 is a point. And 3, 3. So that's 3. So 3, 3. So then, oops, that's ugly. And there you go. And I just want to apologize for all the noise I had to make cleaning my room while I was making this video. So, sorry. I'll go ahead and try to reduce as much noise as possible. And thanks for watching. See you in class.